Hello everyone, thank you very much for watching this live event. We continue today with a lesson on securing reactive applications. Of course, Spring Security, as you know, is one of my favorite subjects and a very important one at the same time. So we will spend this lesson number 7 discussing about using Spring Security with a reactive application. So today you will learn how to secure the endpoints or routes in a reactive application, in a Spring reactive application. I do expect you already know some basics from Spring Security for this lesson. So in case you don't, a better idea is you start with the Spring Security playlist. Otherwise, you might find some of the things that we discussed today difficult. So especially for this playlist, the Spring Reactive one, I expected you know already the basics for Spring applications, the Spring basics, and for specifically for this episode, I expect you know basics of Spring Security as well, because I won't go into details about the fundamentals of Spring Security. I will just start applying Spring Security in a reactive application. If you are watching the event live, of course, don't forget that we have a live chat there, so you can ask questions in the live chat. If you watch the event recorded afterwards, you can still ask questions in the comments section as usual. And of course, find me on LinkedIn and Twitter, and we can discuss there as well. With that being said, today I'm going to start coding directly, and what I'm going to do is, first of all, I will create a very simple application that exposes a reactive endpoint, but I will also add Spring Security as a dependency. Now, for those of you who remember from the Spring Security fundamentals, whenever you add a dependency in a Spring Boot project, whenever you add the Spring Security dependency into a Spring Boot project, Spring Boot creates some default configuration using HTTP basic, creates a user detail service behind the scenes, and the user with a random password generated. So that's what will happen here as well. We will test this default functionality, and then we will see how can we customize, first of all, the user detail service in a reactive application. You will see that we have to use a different class for that. By the way, chapter 19 of my Spring Security in Action also discusses the things that we will look into today. And then after we discuss authentication, we will implement the authorization configuration, and if time allows, hopefully maybe we can take a look into implementing a no-auth to flow, so a resource server using a reactive Spring. If not, maybe we will leave it for the next lesson, so that really depends on the time we have. With that being said, let me just start creating the first project. How should we call it? Spring Reactive C7 E1, and then doesn't really matter, but we will use the latest version, which is 17 at the moment. I will add Spring Reactive as a dependency, and of course the subject of today is security, so I will add Spring Security as well. And for the moment, that's everything that we need for the first example. So I'm clicking the finish button. I wait a bit for the app to be indexed and have all the dependencies downloaded by my IntelliJ here. And after that, I will create a demo endpoint that should be enough for us for our demonstrations. So let me just define shortly a controller. I'm going to say demo controller, and I'm going to add a very short endpoint here. So say we can have a mono of string. As a result, it's just a demo simple endpoint. I will use get mapping for the demo path, and I'm not sure how much it matters for this example, but let's remember that if we want event stream based we need to use the produces and the correct media type. And then of course you can just say them. Cool. So this is the endpoint. So again, I'm going to test what happens now, and because I added the Spring Security dependency in my Spring Boot project, the expectation is that Spring Boot will configure a user detail service out of the box. That's first of all. Secondly, we expect that we will have a random generated password we can use. So is it necessary signed and encrypted JVT tokens? Gabriel, you can give me a little bit more context for the question. I don't know what I'm not even discussing JVT here, so I don't even know what you are asking about. So if you can give me more context, maybe I can answer you, or at least I can tell you where to look for an answer. Cool. So going back, I would like to. I have, and I will show you later. I have a key cloak on port 8080, so that's why I can't use it. So what I'm going to do is I'm going to configure a different port for my application. Otherwise, of course, on the same machine, you cannot have the same port open twice, which is something we know already. So I'm starting the application and I will try using Postman. You can already see that indeed Spring Boot configured a user detail service, and this is the random password that has been generated specifically for this execution. So we can prove that if we try calling the demo endpoint, so HTTP localhost 9090 demo, that shouldn't work. And I should have a 401 unauthorized if I'm calling it without any authentication. But if I use basic authentication, then I use the user and the password that I copied from the console, and that should work. You see the event here with the string contained by the mono. My endpoint returns and 200 OK. So that's a very simple proof that the configuration, the default configuration created by Spring Boot works, which means that my project is fine and the dependencies I used are fine. But we also know that in a real world application it's not enough. So in a real world application you have to configure a way in which you get the user details in case you have users, and that's still a user detail service. I will, however, show you that for reactive applications you have a contract named a reactive user detail service. So for those of you who work with non-reactive applications and Spring Security, you might be aware that the contract used by a non-reactive application is called user details service, and that contract defines the method we have to implement, which tells Spring Security how to get the user details. In terms of a reactive application, it is the same, just that the contract is different, and the reason is different is because we need to use the publishers mono and flux, same as we learned throughout the past 6 lessons. So that's why now in the configuration class I still need to create a configuration class. So let me create it. I have a package and I will create a class named security config, and I will mark it using the configuration annotation. So what I'm going to do now is I'm going to add a reactive user detail service as a bean in my Spring context, and this will be automatically the bean Spring Security will use to find out the details of the user. So if you go, you will see that it's very similar to the user detail service. So you can basically search for user detail service as well to compare them. Okay, so classes. So this is the user details service. This is what you would have used in a non-reactive application. And you see basically the difference, the main difference is just the fact that the user details are no longer just returned as an object, they are returned in the shape of a publisher. And of course the reason is you need to use publishers to work in a reactive fashion, the way we already discussed. So that's why we use a reactive user details service in this case. And that's critically it's very easy, because for the moment in a real world example you would simply implement this, and you can implement the method in any fashion you'd like. So you usually in a real world application probably take the users from a database, from a table, so you simply implement and use whatever you want, Spring Data, I know, Hibernate directly, or JDBC template and so on. We will however step over this, and I don't want to overcomplicate the example, so I'm going to use an in-memory application. So you will see that Spring Security provides an implementation, and this is basically equivalent to the in-memory user details manager. So if you work with Spring Security, you know that in a lot of examples we use the in-memory implementation because it's a simple way in which you can simply store some user details in memory to prove everything is working. So what I'm going to do here is I'm going to say return new, and I'm using this implementation, and I will be able with this implementation to provide some user details. So I'm just say user with username, and I'm creating a user. It's only 3 details you really need to have. The password, let me use 1, 2, 3, 4, 5, and at least one authority is mandatory. And then I'm building the user, and what I'm going to do is I'm simply providing this user as a parameter here. So if you will check the constructor of this class, you will see that there is a constructor that creates the list, the internal list of users through some varargs parameter. So that's the simplest way to use this in-memory implementation. Of course, same as in the case of a non-reactive application, you have to use a password encoder. So that means I have to provide a password encoder for my application. And remember, the password encoder is the object that Spring Security uses to first of all encode, and secondly verify that the password matches its encryption. Usually in my example, as I was using the no-op password encoder, which doesn't do anything. If you don't want that, you can use, in practice the most used is of course the bcrypt, but if you do that, then you also need to make sure that you encrypt the password with bcrypt, because otherwise it won't work. So you have to write something like this. So you set the password of the user detail as being the bcrypt and hash of the plain text password. And again, remember, this is only a very simple demonstrative example, because in a real world application, these details will just be retrieved from the database or from somewhere. But we want just to prove the fact that's working. So let me start the application, and I'm going to try calling the endpoint, but this time I need to use the proper credentials, John and 1, 2, 3, 4, 5. The application started. You observe that we no longer have the random generated password. That's because we defined our own implementation of the user details service. I should now be able to use John and 1, 2, 3, 4, 5 to call the endpoint. And of course, if you want, you can test that without using the credentials. It's not working. So that means that our implementation really works correctly. So pretty easy. Again, if you know the fundamentals of Spring Security, which I do recommend you learn, and if you don't, you can anytime choose the playlist, the Spring Security Fundamentals playlist I have on this channel, or my book, of course, Spring Security in Action. Hopefully, still a very useful book for a lot of people. If you know the basics of Spring Security, then it's pretty simple to understand how to apply them also in reactive applications. So that's basically how you define the simplest user detail service using a reactive fashion in a reactive application. Now, the second thing we'd like to do, of course, is applying authorization rules. So once you have defined the components your application needs to for authentication, then the second thing is implementing, of course, the authorization. Now, to implement authorization up to now in Spring Security, we were extending the web security configurer adapter class. In reactive applications, you don't do that, and even in non-reactive applications, starting from the latest version of Spring Security, web security configurer adapter is deprecated, and it's of course not recommended use it anymore. We have a different fashion of applying the authorization rules using a security web filter chain. So what does that mean is, instead of extending web security configurer adapter and overriding the configure method, that's something you might be used with, I'm simply going to define a bin of type security web filter chain. That method will need a server HTTP security instance that we get. It's already configured in the context, so we don't have to configure it ourselves. We can simply inject it directly in a parameter. The server HTTP security will allow us to create something like a build in the end, of course. Build, I said. Okay. So this is how we create the security web filter chain, where of course we do need to apply some configuration. I just wanted to show you that you create a bin. To create it, you need a server HTTP security. You can inject it directly from the context. Don't worry about it. It's already there in your Spring Boot application, pre-configured by Spring Boot. And what you create is this security web filter chain, which, as the name suggests, is a filter and will apply all the configurations you write here on the HTTP requests coming through your application up to the controller, of course. So basically the thing you will configure is, first of all, the authentication method. Let's start by still using HTTP basic. I will, however, show you that you can implement any kind of authentication method that you could implement also in non-reactive applications. So, for example, if you want to make your application a no-auth2 server, you can do that very easily. And I need to use an AND here. And what I'm doing basically usually is I'm using indentation in such a way which is very comfortable for me to read where some configuration starts and where some configuration ends. You will see that, especially in a real world application where the configuration might be a bit longer, is more comfortable to use kind of an indentation technique to make your code reading easier. So now it's basically just saying I'm using HTTP basic, and of course is the same places where you can say and authorize exchange. If you do remember, in non-reactive applications it was called authorize requests. In reactive applications the same is called authorize exchange. So we say authorize exchange, and then you can use matchers. So you can simply, the easiest, use path matchers and say everything prefixed with the demo path needs authentication. And you will basically see that we have the same way of writing the authorization rules as you might already know from non-reactive applications. Basically, it's kind of wrong what I'm saying now. It's I should have said with web security configure adapter, because now you anyway use this way also with non-reactive applications. So very simply just apply the same way the authorization rules using matchers, using the rules. It's just called authorized exchange, and you need to build this way the object of security web filter chain, which will take care of all the configurations you make here. So in my case, what I wrote here is I want to use HTTP basic, and I want the demo endpoint and whatever is under the demo prefix to require authentication. And then I use the build method of the builder to build the web security web filter chain object. So if I'm running again, you will basically see in this case that we have the same behavior. So the demo endpoint will need authentication, but then I'm going to extend a bit my configuration to prove that I'm really doing something here. And I will add a second endpoint for which I will simply say that is permitted to any request. So if I'm going here, you should still see that to call the demo endpoint correctly, you need the authentication. And of course, if you don't provide any authentication, you experience a 401 unauthorized. I can add a second endpoint. So let me just add a second endpoint, which is say hello. Hello and hello. Okay, and what I'm going to do now in my security configuration, I can say, well, but for hello or any other exchange, you can access the endpoint or route without needing authentication. So if I do add this rule, of course, demo will still require authentication to call the route. But the test endpoint will not require authentication. So I'm restarting the application, and I'm going to test this to make sure that it works the way I'm telling you it's working. So again, if trying to call the demo endpoint with no authentication, we get a 401. If trying to if trying to call the hello endpoint, it will give us the hello and the 200 OK, which is what we expect, because the hello endpoint is it doesn't require authentication, so it's basically not involved in any authorization rule that we specified. But we can still call, of course, the demo endpoint if we use the proper authentication method and credentials. So you can still call the demo, and to get a 200 OK, of course, you need to use the authentications. That's what we said here. So it's pretty easy. And then, of course, same as in the case of web security configure adapter, you can use the denial, you can use the access method, you can apply rules very easily on either roles or authorities, just using the has any authority or has any role. So pretty much the same thing. Again, I'm not going to discuss the fundamentals of Spring Security, and I do invite you use the Spring Security fundamentals playlist for that. But if you already know how to use Spring Security for non-reactive applications, then it's very easy to adapt it to reactive applications. So that's basically it. If we discuss about the security, the security context, so for this we also have a special version, let's call it like this, of the reactive security context holder, and you will see that now the difference between what you used to what you used to use in a non-reactive application, it was called security context holder. So you were using security context holder, get context, get authentication. The difference now is that if you are in a reactive application, to get the authentication details, you can't use the security context holder. The reason why this had to be changed is pretty easy. In case of a reactive application, there is no longer a thread per request model as it happens in non-reactive. You remember we talked about this in the first lesson. It's a bit more complex behind the scenes. The reactive implementation, the reactive server implementation, it has a minimum number of threads that's treating the requests as tasks instead of creating a new thread per each request. So for this reason, the security context holder itself, that in a non-reactive implementation basically uses thread local behind the scenes, doesn't work anymore. So it had to be changed, and not only that, the implementation had to be changed, but it makes sense to again make it in a way in which you can work with it functionally in the same way in which you implement everything in a reactive application. So instead of getting the security context directly, here you will get a mono of the security context, and then you can use all the methods that we discussed to work with the security context. So maybe you want to map the security context and get the authentication directly this way. So you have the authentication, and then you can do whatever you want further with the authentication. Remember never to use a blocking method. We discussed this in the previous lesson. Anyway, in this web reactive application, if you do use a blocking method, you will get an exception, but using blocking methods is against the reactive approach in general. Does the trailing slash thing we see with ant matchers also apply to path matchers? Yes, basically this is an ant expression here. So this is it even says here ant patterns. It's even easier. You don't have something like MVC matchers or ant matchers or regex matchers. Yes, you have path matchers. So it's pretty easy to implement them. It's just ant expressions here that you have to provide to path matchers. So I hope that answers your question. And the suggestion of a good book to learn Spring Boot. So you can use Spring Boot Up and Running by Mark Heckler. I usually start by recommending that one. And my Spring Start here also uses Spring Boot starting with chapter 7. And anyway, hopefully you already know Spring, because the recommendation is you always learn Spring first and then Spring Boot. I know that there are people out there saying that you can start with Spring Boot directly. I don't recommend that. So my Spring Start here will give you also the basics of Spring that you need to before learning Spring Boot. So I do recommend Spring Start here as well. So Spring Boot Up and Running by Mark Heckler and Spring Start here, the book I wrote. These two books should be more than enough to learn maybe most of the things that you use in real world applications with Spring Boot. Cool. So going back now after these questions, going back to my implementation. So yes, you can do now whatever you want with the authentication. So I'm not going to do anything here, or I don't know, maybe we can just subscribe and print out the details. I don't know, but okay, IntelliJ doesn't want to help me write the code faster, but this is it. So this is the authentication details, and now if I'm going to restart the application and call the demo endpoint, you should see this object printed in the console when I call the endpoint. So pretty much very simple stuff to call. I'm not sure why I don't see it actually printed, because I would have expected to see something, but anyway. It's demo, which is authenticated, and then I use authentication. Anyway, it should be there. I can debug if you'd like, but it's irrelevant at this time, because anyway, in a real world app you would simply use it for, I don't know, some authorization you'd like to make or something. So we can even comment it out. Cool. So that's the way you get the authentication wherever you need inside your application. And what we still can discuss, because we have time, I didn't enter details, and that's a good thing, because I now I remain with plenty of time, is how to use also OAuth 2. So if I want to make this a resource server in an OpenID connector or OAuth 2 system, how do I do that? So it's pretty simple. You see, it's very easy to understand that in this configuration you have the HTTP basic, and which is the authentication configuration, and then you have this part which is the authorization configuration. So what you will clearly see easy is that you can change that for OAuth to resource server, and then you can configure here, and usually what happens is that you configure the JVT, and the most comfortable way is to use the key set URI. So we can do something like this as well. So let us do that. I think this end here is not needed anymore, for this method directly returns the server HTTP request, and here we need the keys URI from an authorization server, and fortunately for us, I have a keycloak running on my machine. So I have a keycloak running right here that we can use. I added this. Oh, sorry for that. So I have actually a very powerful password on my local installation. It's admin and 12345. Yeah, but it's only my local installation, so I am allowed to do that. In the clients, I added this my app here, and I configured my app to have a redirect URI, this one. I also configured it to have 1 hour the lifespan of the token, and we should be able to use the authorization code flow. So what we are going to do is use this keycloak to get a JVT token, and if I'm going here, I need to know the OAuth configuration. So what I'm going to need in my case is this keys URI. So this is what provides me the public keys that my resource server can use to validate the authenticity of the JVT tokens. So you can even try to call this endpoint, and you will see it returns all the key set. This is the key ID, which is the key identifier, and the public key details. It seems that I have 2 keys implemented in configured that can be used by my keycloak. But that's not the most relevant point. The most relevant point is that this one is what you configure in your application here. So, and of course, never do something like this in a real world application. You should define this in a properties file, so that you can change it based on the profile, because it will definitely be a different URL for different environments. So that's why you should define it in the properties file instead of putting it directly in the code. And you should private string is URI, take it using, for example, the value annotation here. Okay, that's better. And that's basically it. So surprising or not, It took me 5 minutes to configure the resource server. I will of course prove it's working, but the idea is that it's extremely easy using Spring Security to configure a resource server. You do have multiple options, so remember that JVTs are not the only option. You can use opaque tokens. If you use opaque tokens, you will need to use an introspection endpoint. You can use even JVTs with introspection endpoint, isn't it? So you can do that, and even Keycloak allows that. You will see you have an introspection endpoint. I'm not going into details because it's not something that that we want. We do see, however, that we have a big exception in the log, and that's because the part related to a resource server comes with a different dependency. So since I started with a simple example and didn't add this dependency from the very beginning, I don't have the details. It's pretty normal that it happens like that. How is called, the resource server dependency doesn't come directly with Spring Security, because it's a big part of dependencies, the packages that you don't, in some cases you don't need, and you are not forced to get them if you don't need them. So that's a good thing. It has been made in a way modular. So that's my exception here, is because I didn't have the proper jars for using this app as a resource server. So let's download this dependency, make sure it gets into our application, and hopefully with this addition we should be able to run it. So how would we use a refresh token here? The refresh token is something you use on the authorization server, not on the resource server. So the refresh token is strictly something used between the client and the authorization server. So you don't use it because it doesn't make any sense. The refresh token is not part of the resource server management. If this is not clear, it might be because you don't understand properly OAuth 2. And in that case, I do recommend you use the Spring Security Fundamentals playlist. You will see there the way I also use the resource server, the refresh token. But the refresh token again is part of the authorization server management, not the resource server. So here you don't use it. That's the only thing I can say about. Is this still not working? That is pretty much strange if it's not working. I will try to also build a Maven because it should work now. I mean, the only dependency we should need is this one. Okay, so it is working. So it most likely has only been a problem on the first build. So now we can use our application as a resource server. So we, of course, in that case, we will need to get a token, and to get a token you can use the token endpoint, or you can simply directly use, if you'd like, the OAuth 2.0 authentication here, and let Postman get the tokens for you. So in that case, I'm simply saying here, so callback, which is the callback URL, and that's correct here. I already have it, since my Postman already knows my authentication URL and token, because I probably used it in other examples, in other presentations. But I'm going to show you where I took this from. So the authorization endpoint, you can find it here. The token endpoint, you can find it here. So what I did is I configured the authorization. I simply copied from the configuration of Keycloak the authorization and the token URL, the client ID of my application, which you have seen earlier in my Keycloak. I named my client that I'm using is my app. This is my client ID. The scope profile, which is a standard scope for OpenID Connect. And of course, you can check that your app has that scope, I think here. client scope, sorry. So this is profile. So you can use any of these scopes. And that's basically that's everything in my case. So that I should now just press the get new access token. And what Keycloak does, it forces me now, you know, when you use the authorization code flow, the user has to be redirected to the authorization server and authenticate, and that's what I'm asked to do now. So I will fill in my user, and then when the authentication is complete, you can say proceed, and you can see that a token has been provided. So this is simply a very comfortable way in which I don't have to put this in my browser. So you see this, we get the access token. You also observe that we get the refresh token because my postman now acts as a client. And the refresh token you were asking previously about, it is a management between the client and the authorization server. So what the refresh token is used, the client uses the refresh token, sending it to the authorization server to get back a new access token and the new refresh token. So always when we discuss about the refresh token, the communication is just in between the authorization server and the client. The refresh token never goes to the resource server. But that's better explained with visuals in my Spring Security playlist, so I do advise you go there. So now what I'm going to say is use token. Automatically the token has been added on my authorization header here, so you can see it. It has been added. So I should be able now to call the demo endpoint with this token. Of course, you can test that it doesn't work when you don't specify the token. And again, back when we have a token, you can use it to call the endpoint. So that's how easy it was to configure this application as a resource server. So it's only a matter of a line of code. And again, I've just shown you what is in 99% of the cases used today. The configuration could be more complex. So you first of all, on the JVT, you might choose to specify the public key on the resource server side. This is something I don't recommend because it makes things very difficult in terms of key rotations, because if you do have the public key on the resource server side, then when you do key rotations, you need now to exchange keys in two places. You need to exchange the private key on the authorization server side and the public key on the resource server, while if you would have had them in one place only on the authorization server and use the key set URI as I was demonstrating earlier, the key rotation needs now to be made only on one place. You might need a JVT decoder, a JVT converter. I think it's what you would use most likely. The JVT converter, authentication converter, allows you to customize the authentication object, and that can happen quite often because you might need to have custom claims in your JVT token. So you can use custom claims that you add on the authorization server side, and then you need a way to read them. And of course, Spring Security can't know a custom claim, can't know you add a custom claim to have it predefined. So in that case, you will have to customize your authentication converter. That's pretty easy to be done. I think there is an example there also in the Spring Security stream where you just create a converter, a custom converter, and you can use it. And even without JVT, because OAuth 2 is not always about JVT. Yes, I know that's 99.99% of the case when we implement OAuth 2 is JVT, but you can have any kind of a token, because the OAuth 2 specification doesn't tell you how a token should look like. So that's why we can even have opaque tokens, and you have a way to configure opaque tokens too. Yeah, let's go back to what we were. Go back to what we were using here to have my example complete again. but I wanted to show you that you have the possibility to customize everything. So no worries, you really have the possibility to customize everything. If in your case you really don't need JVT and you need an opaque token, you can do that. If you really want to set the public key here instead of using the key set URI, you can do that of course as well. But yeah, that's what you will in 99.99% of the cases you will use this configuration, because it's the simplest and the most comfortable in any application. And I think that's basically it, because now if you know to create the user details service, of course this one is not even needed anymore, so you can put them out, because if we configure the keyset URI, you won't use the reactive user details service anymore. But you learned in this video how to use the reactive user details service and the password encoder to define your user management inside a reactive application. You learned how to get the authentication details using the reactive security context holder. You learned the way in which you can apply the authorization rules at the endpoint level. And you also learned how to create an OAuth2 resource server. We didn't discuss, but you can imagine you can do as well, use global method security for reactive applications. I think with that we can say that we covered all the relevant details of what securing reactive applications mean. I hope you enjoyed this lesson. I will put the example as usual on my GitHub account, and you will have it accessible, and I will leave the link in the comment section of this video. Please try it yourself, use it, and try to understand it properly so that you won't make mistakes and implement vulnerabilities in your applications. Security is a pretty important subject, and it matters attention. It makes sense to be attentive on it. It deserves all your attention. With that being said, thank you very much for watching the video, and hope to see you in the next one, where we will continue the discussion on reactive applications. Have a great time everyone, and a great time for study further. Cheers!